Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 12C. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19th to 21st of January 2026. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for their presentation and 2 minutes for question answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remark. If you have any query or remark, you can write it to me in the chat box. Just before we get started, I'd like to introduce you all with today's session chair, Dr. Vishal. Dr. Vishal Dr. Vishal Gangadhar is an associate professor at the D.Y. Patil School of Engineering, Pune, India. His primary areas of expertise and research interest includes embedding systems, electronics and communication engineering, information and communication technology, and the integration of artificial intelligence with the Internet of Things (IoT). I request our respected session chair, sir, to kindly address our participants.
Hello, am I audible?
Yes, sir, you are audible.
Good afternoon to all the participants first, to Karthik and all the presentee over onto this online platform. First of all, I congratulate all the participants that your paper is being shortlisted for this particular international conference, SmartCom. Hope you will be with your presentations and all the best for coming session.
Thank you, sir, for motivating our participants. Now we'll be starting with our first presentation. For the first presentation, I like to call the presenter Prachi Ankush for the paper title A Survey on Hand Gesture to Text and Voice Conversion System for the Voiceless Using AI Based Computer Vision. I request the presenter to kindly proceed with their presentation.
Am I audible, sir?
Yes, ma'am, you're audible to us.
Okay, I will share the screen.
Okay, ma'am.
So my screen is visible to all?
Yes, ma'am. Please continue.
Okay, I will start. Okay, so good morning, respected chairperson and panel members and everyone present here. My name is Prachi Ankush and I am currently pursuing my second year of BTech in Computer Engineering, Software Engineering at Vishwakarma Institute of Technology, Pune. And today I am presenting on behalf of all the authors. The title of our paper is a survey on hand gesture and voice conversion system for the voiceless using the AI-based computer vision. So this paper focuses on how artificial intelligence and computer vision can help the speech impaired individuals to communicate more easily by converting the hand gestures into text and then voice. So the next slide is. Okay. So this slides explains the problems we are addressing. So many speech impaired peoples use hand gestures as their primary mode of communication. However, these gestures are not universally understood by everyone. So because of this, they often face communication barriers in daily life, such as in public places, schools, or workplaces. So therefore, there is a strong need for an affordable real-time system that can convert that hand gestures into a text and speech. So allowing that independent, effective, and confident communication. So methodology of our project. So this slide explains the overall working methodology of our system. So first, the camera captures the live video of the hand gesture and the video is converted into a frames. Next, the image processing is applied to improve the image quality by removing the noise and adjusting the brightnesses. After that, the system performs hand detection and segmentation to separate the hand from the background. Then the important features is such as the hand shape and the finger positions are extracted. These features are passed to a trained machine learning model that we use to recognize the gesture. And finally, the recognized gesture is converted into a text, and then using a button, we can convert it into a speech. So enabling a effective communication. So what are the technologies we use? So basically, this slide shows the technologies we use in our system. So we use a computer vision and image processing to capture and analyze the hand gesture from a live video. And machine learning and deep learning, especially convolution neural networks, which is a CNN, are used to accurately recognize that gesture. And Python is used to as a main programming language in our system. And OpenCV is used for a real-time image processing and hand detection. Then TensorFlow, Keras, and Scikit-learn, that are some types of packages we install on command prompt, are used to train the and evaluate the models. And finally, the text-to-speech technology is used to convert a recognized text into voice output. So let's see the system flow diagram. So basically, this slide shows the system flow of our hand posture recognition system. So first, the camera captures the hand image. Then the system performs hand detection and tracking. Next, the hand region is segmented from the background, and the hand posture is then recognized using the trained model. So we trained a model for this to recognize a particular hand gesture. And finally, the output is generated in the form of text or voice, making the communication easier. Let's see the architecture of the system. Okay, so these slides explain the architecture of our system. Basically, we use a 360 by 360 hand image is given as an input to a model, and the image passes through a convolutional layers, which extract the important features such as edges and the hand shapes. And max pooling layer reduces the image size and removes the unnecessary details. And as the image moves deeper into the network, the system runs a more accurate and meaningful features. Finally, the output layer where they classifies the gesture into a four classes, enabling the accurate gesture recognition. At the end, the gesture get recognized. Next slide is a comparative analysis. Let's see. That is a comparison of our results. So basically, these slides compares our proposed system with the existing approaches. Means why we developed this? For before this, a glove-based system provides about 90% accuracy, but they are more expensive and not portable. So an existing vision-based CNN system achieved around 92% accuracy, but they are usually do not provide the voice output. So in our system, it achieves a 96.5% accuracy using the media pipe, TensorFlow, and text to speech. And it also supports a real time text and voice output using just a simple webcam, making it more practical and user friendly. So, what are the different future scopes of our project? So, basically, this slide describes the future scope. This system can be extended to support multiple languages. Okay, so now we are just going to using the language like ACL, that is American Sign Language. So in future we can use multiple languages. So we can use Marathi, Hindi for our India, like whatever different languages we use in our India. So we can develop our project in multiple languages. So many person can use this application, and it can be developed as a mobile application for better portability. So now it is a web, and it is run on a command prompt. Basically, it is run using a command. So we can use it in a mobile application. Okay, we can develop a mobile application for this one. Anyone can use it. It is portable to everyone. And next one is a gesture recognition accuracy. It can be further improved in advanced deep learning models, and the system can be upgraded to recognize the continuous gestures and complete the sentences. And additionally, we can also do it in offline functionality can be added for use in a remote or low network areas. So these are some future scopes we can develop our system in future. So thank you everyone. Thank you sir for your attention.
I request the respected session chair, sir. Sir, do you have any questions?
Yes, Prachi, am I audible?
Yes, sir, you are audible.
Prachi, hello.
Sorry, sir. Yes, you are audible.
Okay, nice presentation. Your
Thank you,
topic is
sir.
innovative.
Yes, sir.
I want to ask one question only.
Okay.
What are the main challenges in real-time hand gesture recognition for assisting voiceless using AI?
Okay. So basically, today's challenges is the system are not accurate. So that to convert the hand gesture into a text, so you can make it more accurate. The accuracy, we can improve the accuracy. And for voiceless, now, so actually this is my EDI project. So I developed this project. So it is half completed. So now what happens when a user or any person shows hand gesture, the hand gesture is not accurately recognized. So we can improve accuracy using different multiple images. We can make train our model using different types of images. So it makes or creates that project more accurate. So accuracy is the main problem that is not currently available. So we can improve our
Okay,
accuracy.
okay. Is there any specific technique according to your survey which is applicable to computer vision or we can say for your guest recognition system?
For train the model, sir. I didn't
Yeah,
understand
you
your
have done
question.
the survey, na? So which method is preferable according to your survey?
Okay, okay. So basically, sir, I trained a model in a CNN model, which is a convolution neural network model. So for each if each alphabet gestures, I collected a different types of images and I feed them in a one model that is a CNN model. And using a Google Colab, I trained that model.
Okay, thank you.
Okay, thank you, sir.
Thank you, sir. Now we will be proceeding towards the next presentation. For the next presentation, I like to call presenter CHS Ramadhu for the paper title Advanced Machine Learning Techniques for Underwater Image Denoising and Enhancement. I request the presenter to kindly proceed with their presentation.
Good morning, sir. Good evening, sir.
Good
May I
evening, sir.
audible?
Yes, sir, you're totally audible. Please
Good
proceed.
evening.
Okay, okay, sir.
Sorry, sir, for disturbance. Can I leave, sir?
Ma'am, it is appreciated if you take if you stay till the end.
Okay, sir, no problem. I will stay.
Thank you.
Yes, Ramudu, you can continue.
My screen is visible to you, sir.
Yes, sir, it is visible. Please continue.
Yeah. Good evening, sir. Today I will present our work on enhancing underwater images using a sophisticated deep learning model. So the main problem,
Please,
the problem st
please follow slideshow presentation.
Okay, sir. So we are going to abstract. The underwater images are crucial for marine exploration and archaeology and robotics. However, they suffer from low visibility, pure
Sorry to
contrast,
Hello.
interrupt,
and
sir, but your presentation slides are too small and they're not clearly visible. We request you to kindly move towards slideshow or put them in the presentation format, in the slideshow format.
okay, sir. 2 minutes, sir. I will.
Please enter the button F5.
Now it is clear, sir. Hello.
So you may please continue.
Okay, sir. Coming to the problem statement, underwater images are crucial for marine exploration, archaeology, and robotics. However, they suffer from low visibility, poor contrast, and they are unnatural color cache due to the light absorption. So, for that, we developed a machine learning model that automatically learns to correct images. We use residual UNet and encoder and decoder. We use the model called residual unit and encoder and decoder neural networks. The mechanism works as encoder. It learns the overall structure of the image, and decoder is reconstruct the image using the skip connections to retain the key details. The goal of the goal of this project is to get a clear and visible image. We train mod we training model. We optimize a Adam optimize with a learning rate of $1 to $4, and also use a loss function, mean squared error. We also used 100 data models to train, and mm, and also we evaluate the matrices like PSNR and ISSM to draw a graph. These are the data sets we train for our model. Mm. So, sh- performance analyze training approach both PSNR and ISM values increases stably over 10 approaches, and a smooth decreasing trend in training loss indicates the proper learning with significant outfitting. Structural feasibility rising SSIM score confirm that reconstructed images remain highly similar to the original quality target. So these are the two graphs which indicates the PSNR and ISM over mm, train rate and 100 data, and these are of the predicted output, which shows the first input a underwater image which is poor unnatural color. So later we predicted enhanced we contrasted images, and then we get in clear images. Conclusion, the residual unit successfully overcomes the limitations of conventional methods, delivering the superior contrast and color correction. Future elements integrating the attention mechanism or transfer the models to better encode global constraint. Training and even large data sets to improve the versatility and real-time implementation, deploying the model and automated underwater vehicles for live video enhancement. We have an hello, sir.
Yes, sir, you are audible. Please continue.
Yeah, if you have any questions, I completed my presentation. If you have any questions, you can ask regarding this.
Okay. I request our respected session chair, sir. Sir, do you have any questions?
Hello.
Uh, yes, sir.
Mm, what challenges actually means underwater images, particularly for underwater images, you have faced while performing your methodology or experimental analysis?
While while training the data, we face them challenge while training a lot amount of data, because you traded two types of data, which which one UEP data sets and also another model data type. So it takes a huge amount of time to train our data.
Okay. Uh, are you able to state some applications of enhanced underwater imagery, real world applications?
I can't understand, sir. Can you repeat it again?
Are you able to state some real world applications of enhanced underwater imagery? The techniques which are using underwater images onto which they are applying some machine learning or AI based techniques for image denoising or enhancement.
Yeah, you also applied some techniques like machine learning techniques, uh, residual unit technique used, and also encoder decoder technique used to enhance your images.
Okay, thank you.
Thank you,
Thank
sir.
you.
Now we will be proceeding towards the next presentation. For the next presentation, I like to call presenter Diksha Narang for the paper title Deep Learning Based Fatal Health Classification, a Systematic Literature Review. I request the presenter to kindly proceed with their presentation. I request the presenter to kindly proceed with their presentation. We'll be moving forward. For the next presentation, I like to call presenter with three for the paper title Development of Green IoT Portable Vermicomposting Model to Support Organic Waste Reduction in Indonesia. I request the presenter to kindly proceed with their presentation.
Okay, thank you very much for the opportunity. Good afternoon, everyone.
Good afternoon, ma'am. Please proceed with your presentation.
Okay. Can you see my slide?
Yes, ma'am, it is visible. Please continue.
Okay, thank you very much. Let me present our paper with the title of Development of a Green IoT Portable Vermicomposting Model to Support Organic Waste Reduction in Indonesia. The background of this research is started from waste management remains a major challenge in Indonesia, which is only 59.53% of waste is managed nationally. Food waste contributes 39.39% of total waste, and manual waste processing causes environmental issues. So the data is taken from National Waste Information System, and this is some of the waste which is only uh, throw away on the street. Yeah, and it's everywhere in different cities in Indonesia. So from this problem, we create a problem set. We create some problem statement here that some techniques, particularly vermicomposting, can be taken uh, as a method to uh, manage the organic waste, which has the largest composition. And vermicomposting in Indonesia is still done by manually and inefficient way. So we need a system to automatically monitor and control this. And we also will integrate this system with digital and circular economy. So this is some of a picture we taken from uh, vermicomposters in Indonesia, which only doing manually. And so the research objective is to develop green IoT-based portable vermicomposting, or we say in a shortened way, GEOT PVC. The objective is to automate composting, to monitor it, and to support green economy and sustainability. So the methodology we use here is the SRM, or Design Science Research Methodology, which has 6 stages. The first one is problem identification, and the second solution proposal. The third one is prototyping, the fourth evaluation, the fifth statement of learning, and the last one is communication and dissemination. So we have done some literature reviews here. For example, there are research from Abdel Safi and Mansour in 2018 has focus area in solid waste management, but the limitation is no digital or IoT-based solution proposed. There are some research for vermicomposting, which integrated using of IoT, for example, Aquino et al. 2019, and then Mohapatra et al. 2033, Sahu et al. 2033, yeah. Umar et al. 2024. Yeah, most of them are from India actually, and from Indonesia is still lack of research for automatic vermicomposting. Yeah. So this is we started from here. We take that this is as a limitation or research gap for our research that in Indonesia still lack of automated vermicomposting and integrated with IoT and also some machine learning model. So the system workflow here we use ESP32 microcontroller, and as sensors we use some sensors such as temperature, humidity, pH, and gas sensors. And we also has Wi-Fi connectivity, which send the data sensors every 2 minutes, and then cloud platform using ThinkSpeak or Firebase. And then we have 2 other interface such as web-based dashboard for administration, and then mobile-based application for the users to control automatically from their mobile phone. The system component itself has 4 components, 4 major components. The first one is sensor data collection, and then the second one data transmission to cloud. The third one is real-time monitoring dashboard, and the fourth one alerts and notification. So this is some output from our real-time system, yeah, which can be seen from the dashboard from our admin or administrator. Yeah. So from here we can see the data taken from the sensor, such as the humidity, and then the pH, the gas, and also the temperature of the soil and the air. This is the picture of our prototype. We call it as Geode PVC, as a portable vermicomposting bin, where we can take it everywhere and put the sensors on the vermicomposting bin. And it has integrated IoT sensors and suitable for household and communities. We have evaluated and tested this prototype in terms of technical performance, and we have 5 indicators, which are sensor data accuracy, real-time monitoring, system connectivity, system responsiveness, and portability. For example, for sensor data accuracy, the evaluation results shows that the sensor readings are stable and consistent to capture temperature, humidity, pH, and gas parameters. And the value we may say that the value is quite high. Yeah? So we have 5 value, very low, low, medium, high, and very high. For indicator real-time monitoring, we have frequency and reliability of data transmission to cloud. The evaluation result shows that the data is able to transmit it every 2 minutes without interruption, so the value is high. And the system connectivity shows that the ESP32 Wi-Fi connection is quite stable. And this Wi-Fi connection to ThinkSpeak and Firebase is stable also. So we may say that the value is high. Then also the system responsiveness is able to make an alert successfully generated under abnormal conditions. For example, when the temperature is very high, so it will create an alert, and the system is successfully trigger alert and notification, so the value is high. And in terms of portability, the prototype is to relocate and deploy, then so the portable being usable in multiple location, and we may say that the value is high. From this research, we evaluate the impact of our research, that it able to reduce food waste, and it give potential economic benefits. It supports circular economy and support SDG 11, 12, and 13. SDG 11 is sustainable cities, SDG 12 is responsible consumption, and SDG 13 is climate action. For the conclusion, GeoPVC is effective and sustainable, is proven from our testing and evaluation, and it support green digital waste management and scalable for real world deployment. For our future work, we will integrate this GeoPVC with AI-based compost quality prediction, long-term deployment, and smart city integration for higher scale. And last one, we would like to acknowledge for express our gratitude to our Ministry of Education and Culture Republic of Indonesia for giving us National Applied Research Grant for model out. Thank you very much for your attention. Maybe if there is any question.
Okay, Virti. Is it Virti, na?
Fitri,
Vitri. Okay, nice presentation.
thank you.
Can you explain how actually IoT integrates with AI for improvement in traditional vermicomposing system?
Okay, so for our future works, we will integrate this IoT with AI to make a prediction. For example, when the compost will be ready, uh, from our input,
Actually,
yeah, from our
actually,
data
I want to
sensors.
know on which physical parameters or on which parameters you have worked, so that those
Oh,
parameters get improved with the help of AI and IoT.
okay. No, in this prototype, we haven't integrate with AI, so it's we only integrate with IoT. As our title here, development of green IoT portable vermicomposting. So for our future work, we will integrate with AI. Not in this research, sir. Not yet.
Okay, okay. How does your model, when it will be ready for use, how it will contribute to achieve or obtain the sustainability goals?
Pardon, sir?
How your model, whatever you have designed, will help in improvement of in gaining the sustainability goals?
Mm-hmm. Yeah, because we can reduce the organic waste. We already try in our partner. Yeah, we have partner to testing in real case. Yeah, and we have successfully reduced the organic waste by putting the the geode PVC. This is, for example, the soil we get from our partner, yeah, before we use the prototype. They just put the soil on the under the sunrise, yeah, under the sunrise for maybe months, yeah, for maybe months. And the soil result is still very bad for warm environment. This is before we put our system, yeah. But after we put our system, the quality of the soil is increasing in a better way, much better, because we can control it.
Okay. Thank you.
Thank
Thank
you,
you.
sir. Now we'll be moving forward for the next presentation. For the next presentation, I like to call presenter Shivang Patel for the paper title Foundation Models and Generative AI for Cross Modality Medical Imaging and Early Disease Prediction. I request the presenter to kindly proceed with their presentation.
Yes, sir.
So please proceed with your presentation.
Yes, sir. My screen is visible, sir.
It's loading. Yes, sir. Now it is visible.
Okay. Good afternoon, respected session chair, distinguished delegates and colleagues. Am I audible, all of you?
Yes, sir. You're totally audible. Please proceed.
Yes, sir. Okay. So myself, Dr. Shivang Patel from Dr. Babasaheb Ambedkar Open University. Today I will present our work titled Foundation Models and Generative AI for Cross-Modality Medical Imaging and Early Disease Prediction. The paper ID is 515. This work is joint with Dr. Nilesh Modi and focuses on building the robust medical AI systems when clinical data is incomplete. So now I am presenting our paper, research paper in this today's conference. The contents that we are going to cover, that is abstract, introduction, literature survey, proposed architecture framework, research design and implementation. Then after result and discussion, then future work, conclusion and references. Now, the abstract, that is exponential growth of multimodal healthcare. As we already aware that multimodal healthcare data, it is not focuses on the unimodal, but multiple data. It may be radiology images, it may be pathology data, pathology images, as well as the electronic health records that presents a transformative opportunity for precision medicine. So basically what happens, a clinician rarely relies on a single MRI scan. Instead, diagnosis involves combining structural images, that is from MRI, functional images like PET, and the clinical text from electronic health records. So however, most AI systems today are unimodal, and furthermore, the scarcity of the aligned multimodal data set and the prevalence of missing modalities in clinical setting that hinder the deployment of robust predictive model. So basically, our paper that proposes cross-gen medical foundation models, a novel unified framework that synergize the foundation model with generative AI to address various challenges that is available or which is exist in the unimodal system. Now we are introducing the generative imputation module utilizing the latent diffusion model there to synthesize missing imaging modalities. Now what happens, suppose sometimes in multimodal imaging framework, we are considering multiple images, multiple inputs, say for example MRI as well as the PET scan also for precision output. But suppose PET scan is not available. In that case, what our model will does, it will create that synthesizer pattern from the MRI images. So basically, the main fundamental of this generative imputation module, we will explain in detail in architecture, that we will developing that PET scan from the MRI. Now these are processed by hierarchical cross-modality attention transformer that fuses visual features with clinical text embedding. Till now, whatever the model that are existing, they are not combining whatever the clinical text with their prediction in particular output generation. But we are combining this visual as a data as well as the textual data with the help of the concept of natural language processing. So we validated cross-gen med FM, that is our proposed model, on ADNI dataset, that is for early Alzheimer disease predictions, and the patients experimental results that demonstrate the diagnostic accuracy is 98.2% and OCROC of 0.99%. So these are the keywords that we are using here. Now, the paradigm of medical diagnosis is undergoing a seismic shift from symptomatic reaction, reactive care to proactive, data-driven early prediction. Now, modern clinical decision making is inherently multimodal. Radiologists rarely diagnose a complex pathology like glioblastoma and Alzheimer's disease based only on MRI scan. Now, instead, we are synthesizing whatever the MRI scan and we are generating the PET images. Now, despite this, majority of artificial intelligence system in healthcare that remain siloed, optimized for single modalities, either computer vision or the NLP. But our model that proposes that combining both this data, that is visual imaging as well as the text data. Now, the emergence of foundation models, that is large scale self-supervised model trained on vast corpora of data. So some of the models that are already available in the literature survey, but ultimately the major bottleneck, that is the data completeness. So traditional supervised learning model that fails normally when input modalities are missing. In some of the cases, we are not having all the modalities available with us for experiment or for the input in the model. In that case, such a model that may become fail. Now integrating generative AI directly into diagnostic pipeline. So what happened here? We are just putting our this generative AI concept model and generating whatever the image, MRI image, and generating the PET scan from those whatever the available images. So the accuracy of the model as well as the data that we are find, that is more compared to any other model. So as we are discussing the motivation, so basically existing multimodal frameworks typically employ late fusion, where decisions from independent networks are averaged. This approach fails to capture the intermodal feature interactions. Now, there is a need of a framework that are resilient, that means capable of functioning with incomplete data. As we have discussed, we are our proposed model. Suppose you are having some missing images, such a say for example, in our experiment, a PET data is not there. So we have just removed the PET images or PET labels from our experimental data from ADNI database, and we have implemented our proposed framework on those database, and still we are getting the result that is more accurate compared to other models. Now, context aware, that is another need for the framework, that is able to fuse pixel data with textual clinical context. So we are improving our system, our model, with combining this multimodal initiality, that is pixel data as well as the textual data both. And the generalization, right now our model that is focusing on Alzheimer disease, but in future we are planning to generalize this model for other disease also. Now, which are the contributors, main contributors of in our proposed model, that is cross-gen med FM, that is medical foundation models. So basically our key contributors are this GIM, that is generative imputation module. Now we propose latent diffusion based mechanism that synthesize missing modalities in the latent space. Now, as we have already know that what is latent space, so it is not required to much space, but compared to whatever the actual image space, it is required a lesser amount of space in latent space, that preserving the cementing consistency, but without needing the full resolution. So this module that can help us to create or generate the realistic image that is not actually there, it is missing in actual data, but with the help of this GIM, we are creating that particular images. Now, second is cross modality. attention fusion. So novel transfer architecture that utilizes cross attention hits to dynamically weight visual token based on the clinical text embedding. We are combining visual data as well as text data by using the natural language processing. Now, empirical validations. So we have already discussed that we are using that ADNI dataset, that is Alzheimer disease neuroimaging initiative dataset. It is freely available. Now demonstrating supervising performance in early mild cognitive impairments, MCI to AD conversion. So what we are doing, we are just experimental our model on the patients that are having the symptoms of MCI, and they are now moving to the Alzheimer disease conversion. So we are applying our model on multiple data, so you can get idea how this model that will differ from the other existing models. Now, basically literature survey. So foundation models in medicine, there are multiple models available that are in the literature. They are having some different findings and different advantages and disadvantages. We are not going to discuss all here, but some of the author that we have mentioned here, that is Moore, Red FM, they have created the model, that is clip and align models are also there, but they are having some diagnostic limit or some problem. And now cross modality learning. So multimodal learning aims to emulate the clinician's synthesis of the information. So again here the cross modality learning, because generally what happened right now only single modality or unimodal learning or models are available, but here cross modality we are combining in our experiment, that is visual data as well as the textual data. Now generative AI for synthesis and imputation. So basically that is generative adversarial network that we are using here. So normally what happened, whatever the data available in the case of images, MRI images are available with us, but in some of the cases the only MRI data is not sufficient to diagnose something. Say for example here it is required to PET data also. So we are train our model to generate that PET data from the MRI. So this way we are using this generative AI concept here in our proposed model. Now integrating the diffusion process within the predictive loop that impute the missing latent feature.
Sorry
Now
to
what are
interrupt, sir, but you have 1 minute to conclude.
oh, okay sir, so I'm just uh, explain this basic architecture, sir. That is the main core. So basically what happens, sir? So first we encode structural MRI using Swin transformer backbone initialized from medical foundation models. Then after clinical text and metadata are encoded by using clinical BERT model. And then after if PET is missing, we activate the generative imputation module, which uses a latent diffusion module conditional on MRI features to synthesize the PET representations. Now we are just one look at these are the data that we are using. Sample size, we have used 1250 subjects for 400 cohort, that is normal control, mild cognitive impairment and Alzheimer disease. Now based on this we are using this hardware software. These are the specification that we are using in our research study. Now this is the table that depicts the demographic as well as clinical characteristics, and that is the bifurcation among all that is normal control, mild cognitive impairment and Alzheimer disease. Uh, then after, which are the different models that we are using, that comparative study is depicted here in this slide. That is residual network 50, then after visual transformer, then after transmed model, and the last one is cross-gen med FM, which is our proposed model. In first case only MRI that will be used in the experiment. In second one MRI plus text, that is used in third MRI plus PET plus text. And in our model, in our proposed model, if the PET is not available, with the help of generative AI, we are generating that PET images from the MRI, and we are combining with the text data, and we are getting the accuracy 98.2, and the other sensitivity and specificity and OCROC values are also available here, which is, and these are the pictorial representation of that comparison. This is classification accuracy, ROC comparison. Then ablation study, as we have already discussed, some of the components we are removing and then try to incorporate all those into our model. And the same way we are just removing our PET labels from the images and trying to input all those images in our model. Then the effective of generative imputation on performance, early prediction. After 24 months, this achieve accuracy that is different. Standard clinical accuracy that is typical this 70 to 75%. Early diagnosis prediction confidence. The chart is ever. Then MCI to AD conversion prediction here also our model that performs well. Then we are just this is our future work, that is federated learning. We are planning for oncology and real-time age deployment. And with the time limitation, just I am concluding my presentation. This results present this cross-gen medical FM, that is the proposed model. Here with the help of this, we are finding out the missing data, and we got the accuracy 98.2 in the case of Alzheimer disease prediction. And so this AI generative model that is helpful and more accurate compared to other models. These are the references that we have used. And is the last slide. Sir, any
I
question, please?
request our respected session chair, sir. Sir, do you have any questions?
Am I audible?
Yes, sir.
Okay. Nice presentation, Doctor.
Thank you, sir.
What are the foundation models actually been incorporated in medical imaging?
Basically, sir, whatever the models that are created based on the different authors, they are given their different names. But whatever the basic techniques they are using, they are the base that is generative AI models they are using. In all those cases, what happened in some of the image restoration, they are used for image restoration. Some of the data
specific generative AI models I am asking about.
That is a transmed model that is available, and that residual model is available. Hello. Google BERT is also
okay.
there.
Are there any concerns about generative AI? Ethical concerns I am speaking about.
Yes, obviously, sir. There are some ethical concerns because ultimately this model that is the machine oriented, whatever data we are feeding, if any of the error in those data, then it will predict wrongly and it will generate the wrong output. So it may create a problem in terms of ethical.
Okay, thank you.
Okay, thank you very much, sir.
Okay, sir.
Thank you.
Thank you. Now we are moving towards the next presentation. For the next presentation, I like to call presenter Vidhi for the paper title Heart Rate and its Variability from Short-Term ECG Recording as Potential Biomarkers from Classification Using Machine Learning. I request the presenter to kindly proceed with their presentation.
Thank you, sir.
Ma'am, please continue with your presentation.
Yeah, sure. I'm just sharing my PPT. A very good afternoon to all of here present here. Myself, Vidhi Sutaria, and I am representing this paper with Dr. Arpit Jain, heart rate variability and its potential biomarkers, ECG recordings using machine learning. This paper includes a basic concept of ECG. Now, I would like to just elaborate. ECG is electrocardiogram. This particular technique is used to monitor the heart activity, basically in terms of whether your heart is having an issue or not. Thus, in my study, I have used a data set named PTBL Excel dataset, which I will be elaborating in the coming parts. This data set is used for classification. The dataset contains various images of ECG of multiple patients, and I have used this dataset to make classification using the concept of machine learning. Now, as in this fast-paced world, the maximum cardiovascular disease are being rapidly growing. So this ECG can be a major marker for identifying the heart activity. The figure which is shown in over here represents a small and a very small portion of an ECG. The markers you can see there are P, Q, R, S, and T. A small ECG contains this every markers in repeated pattern. So if a this type of one single pattern, you can see a multiple repeated pattern. The whole ECG recording is there. Now, for an ECG recording, there is always a time duration mentioned. For this data set, before moving forward, I would like to elaborate the concept of what are these waves related to. The P wave represents the upper heart chamber. When the heart contracts, the P wave gets activated. Then comes the QRS waves. This is called a QRS complex when it comes in the lower chambers, and when the heart contracts, this waves activates, and as and when the heart get relaxed, same like our breathing pattern, the T wave gets relaxed. So these are the major notations which are used in an ECG. This notation gets on repeated in the whole ECG format. So if you have seen an ECG goes up and down, up and down, up and down, depending on the heart issue. So these are the basic notations used in the whole ECG. Using these notations, I have calculated the variability features of the signal. This is the data set which I've used. It is a PTBXL data set. This data set contains 21,799 ECGs from 18,869 patients. The total recording of ECG is 10 seconds. The total number of ECGs are greater than the total number of patients. The reason is there are some patients who are having repeated. For example, a patient is coming for a follow-up. So there may be multiple ECG recordings of one patient. So that is the reason the total number of ECGs are greater than the total number of patients. So for this data set, the total recording length for every ECG is 10 seconds only. Now in the 10 seconds, what recording are there? This particular data set has two files in terms of signal, the data file and the signal file. I have converted it into the signal, and then I have calculated the heart rate. Before moving forward, we would like to elaborate the data set. The data set contains five different kind of total classification that every ECG falls into. There are some particular records where the combination of classes can be there for one single ECG. So first is the normal, when the person is having no issue in the heart. The second is if the person is having an irregular heartbeat, it is called conduction disturbance in medical terms. If a person is having a heart attack, it is called MI. The code is specified in the data set itself, which is in the column SCP code. It is called myocardial infarction. Third is the thickening of the heart muscle, which is called hypertrophy, and it is denoted as HYP. When the blood flow of the heart is reduced, it turns out to be STTC. The waves STT gets changed. So these are the total number of records which are available in the whole data set, and these are the classes. The sample size, it is given class-wise description that the normal is having now 9,000, conductional disturbance 4,000 something, STTC, MIN, hypertrophy. These are the total number of bifurcated records in every class. Now this is a normal data set. This is a sample which I have shown it to you, what I have calculated from every image of the ECG. The two gaps between the R peak. The R is the major peak which is representing the whole ECG in the signal. The R is the highest peak, and the gap between two R peaks is called the RR interval. So if, for example, one signal is having 10 seconds of recording, maximum there can be 7 to 8 R peaks. So every interval is being calculated using my Python code in Google Colab. And I have already also calculated peaks from P, Q, R, S, T, the gap between the RR gap, the gap between the P gap, T gap, Q, and S gap. So every peak is been identified using the Python code. This is the actual data set. See, this was a sample which just I wanted to explain to you. This is my original data set, which is been converted into the images, and every peak, the colors which is representing blue, red, these are the peaks which are detected in the Python code using Google Colab. So these are the total 5 classes. One sample of every class has been depicted over here. This is one sample data. We can see that just I told you this image. This image, if we are making multiple images, it turns out to be the whole ECG recording. So the highest peak, every peak is being calculated using the Python code in the image, and the value from that particular content is being calculated. What is being calculated? Every every amplitude of every peak, irrespective of P, Q, R, S, and T, amplitude is being calculated. And the major concern when comes out to be bifurcating the ECG records is the gap between the R peak. The R peak is the red peak, which is being depicted over here in the figure. This also is being calculated using Python code and find it out, and a point is placed on that particular peak. Though this is one sample record, again, this is from the data set only. So using this particular calculation, I have calculated every content. First of all is my ECG ID. Then I have calculated the average of the P amplitude. As I told, I have calculated P, Q, R, S, and T, and the average height of every, because there can be, for example, you can see over here, there can be multiple P's over here. So every P is not calculated. The average is taken, the lowest value of the P in the whole ECG recording, the highest value of the P. Same for the Q peak, same for the R peak, same for the S peak, and same for the T peak. All this peak is being calculated. Then comes the average of RR. RR is the R is the highest peak. Average of the RR interval. Every two gap, 1, 2 gap is calculated, 2, 3, the gap is again calculated, the 3, 4, the gap is again calculated. These are called RR intervals. And for every gap, the average of the gap is calculated, the median is calculated, the standard deviation, root mean square. PN25 is the total number of two R peaks which are having minimum of 0.25 millisecond gap. Then 50% is the the total number of peaks gap between where the total number of gap is 0.25 milliseconds. The heart rate is calculated, the gender, age is given itself in the data set, and the final class. Every parameters which is stated over here is calculated for every single ECG recording. So I am having 21,000 ECG recording. For each and every 21,000 recording, every parameter which is stated or visualized in the screen is being calculated, and a whole data set is generated. Now, after the data set is generated, there are chances that one single ECG may have multiple classes. So again, I have bifurcated the data, repeating of the data, because for multi-class classification, I want to do it. So final class, if it is having, for example, conductional disturbance and myocardial infraction, then 2 repeated rows are being done. So whole data set is being bifurcated, and a new data set is generated from the images. So the data set was having every image only. I have calculated these parameters are called heart rate variability features. So a new data set CSV file is being generated using the images. And after this is given to all the algorithms of the machine learning. I have implied decision tree, naive Bayes, SVM, KNN, and random forest, wherein I am having 78% maximum accuracy in the random forest. Still, my work is in progress. I am in plan to add the other machine learning models. I am next planning to add the CNN model, because partially, if I'm calculating, maybe I get the accurate values. Or the third option, which I am planning for my future and enhancement, in boosting algorithm or stacking of the algorithms. So this is my work. Thank you so much. Any questions?
Hello, Vidhi.
Yes, sir.
Am I audible?
Yes, sir, audible.
Nice presentation. Your topic is also
Thank you.
good and social.
Thank you.
What is the importance of this HRV as per as we can say ECG recordings and ECG regulations and human body and heart is considered?
Yes, sir. Sir, heart rate variability is every feature when your heart works, does not work, if it is having a low blood flow, if it is having the thickening, every parameter is included. The content which I have bifurcated represents the heart rate variability features. So these are the features which I have extracted are known as heart rate variability features. Till now, what work people have done, that they have worked on image processing more in the ECG part, because directly we are getting the images. So now my part is I want to convert this image into a numerical data, so that more we can work on it.
Okay. You have done HRV based classification, na?
Yes, sir.
Which algorithm, which ML algorithm is best suited for this particular experimental analysis?
Sir, currently, according to my data which I have extracted from my point of sight, my random forest works better, but still it is having 78% accuracy only. So I'm still revising the data in terms of CNN and boosting algorithm, so I can get a better accuracy.
Okay, thank you.
Okay, thank you, sir.
Thank you, ma'am. Thank you, sir. Now we'll be moving forward for the next presentation. For the next presentation, I like to call Haida Harbun for the paper title Intelligent Prediction of Sustainable Energy Access Using Hybrid Machine Learning and Bayesian Optimization. I request the presenter to kindly proceed with their presentation. I request the presenter to kindly proceed with their presentation. Ma'am, you're audible to us. Is there any issue? Ma'am, we are not able to hear you out because you're on mute. Kindly unmute yourself. Ma'am, if you're facing some issue, we request you to kindly rejoin the meeting.
Karthik sir, next present.
Okay, sir. We request ma'am to kindly solve the technical issue. Till that, we are moving towards the next presentation. For the next presentation, I like to call presenter Dhanush Gopal for the paper title Next Generation Variant Analysis, a Scalable Toolkit for Population Level Genomics. I request the presenter to kindly proceed with their presentation. The presenter is not in the meet. Yeah. So please continue.
Hello everyone, I'm Dhanush Gopal Battina from University of North Texas. Today I will present next-gen variant analysis using VCF library, why it helps like population scale and performance comparison with common tools. Our motivation is genomics is moving to population scale datasets with many samples and millions of variants. A major bottleneck is not only computational but also like data movement, repeated tracing, and conversions and creating intermediate files. So the key need is a like workflow that keeps VCF and BCF processing fast, memory efficient, and pipeline friendly. Our background tools tools like VCF tools, P-Link, and Cell Scan are widely used, each strong in specific tasks. But in practice, we often combine multiple tools in one pipeline. That adds like extra formatting steps, intermediate files, which increases runtime and makes workflows harder to manage. This motivates using a toolkit that can handle more steps in single streamlined flow. Or problem statement and objective is the problem is scalability. As data grows, we want to reduce runtime and memory without losing reproducibility. Our objectives are efficient handling of large VCF and BCF files, fewer pipeline handoffs and intermediate IOs, and ability to compute population genetics measures cleanly in a workflow. And what is VCF library? And VCF library is a C++ library plus a set of command line utilities for VCF and BCF. It supports filtering, transformations, and statistical computationals. It works well in pipelines, often through piping commands instead of writing multiple intermediate outputs. So it's designed to be like more both fast and practical for real life workflows. Why it's faster? The performance mainly comes from three design choices. First, stream-based processing. It processes variant records sequentially and reduce intermediate read-write operations. Second, better CPU utilization. It can keep cross busy rather than waiting on I/O. Third, efficient access patterns, especially with compressed index data, which reduces unnecessary scans. Overall, it reduces peak memory and improve to output. Our methodology is the workflow is simple. Ingest VCF, BCF to apply filters and transformations. Compute required statistics and summarize outputs. The emphasis is on record by record processing and keeping the pipeline module for tools like workflow runners. So the methodology focus on efficiency and reproducibility rather than like complex reprocessing. Our experimental setup is like we use like 1000 genomics coherent scale data and ran the experiments on a 12 core Intel Xeon 64 GB RAM, Ubuntu 22.04. We compare against VCF tools building and cell scan under the same missions and datasets. And the conditions are we use like runtime CPU usage and memory consumption. And our results is here is the like key comparison. Runtime VCF tool 6.8 hours, peeling 5.9 hours, and cell scan 4.5 hours, and VCF library is like 3.9 hours. So VCF library shows like about like 45% reduced runtime in the comparison memory, and VCF library use like only 1.4 GB of memory, while the others are around like 2.4 to 3.1, which is like close to 50% lower memory. Also, VCF library shows like higher CPU utilization, meaning it spends less time blocked on IO and more time actively processing. And to conclude, VCF library supports like scalable VCF, BCF processing, reducing intermediate IO and lowering peak memory. This make it useful for population scale pipelines where speed and resource use matter. Future work includes like expanding the set of statistics, improving anonymous integrations, and providing package reproducibility pipelines for easy adaptations. And here are like our references. Yeah, that's it.
Now I request our respected session chair, sir. Sir, do you have any questions?
Hello, Dhanush.
Yes, yeah.
What are the current challenges available in population level genomic variant analysis?
At this moment, like there are like couple of challenges. The main challenges are like data scale, IO bottlenecks, high memory usage, and poor integration across tools, which make like population level variant analysis slow and difficult to scale. These are like
Okay, if we consider scalability, what technological support you are getting for scalability in your toolkit?
for technology support in my toolkit. Scalability in our toolkit is enabled to stream-based processing, multi-threading execution, and index-aware region queries, which together reduces IO and memory usage while clock time.
Okay, thank you.
Thank you.
Thank you, sir. Now we are proceeding further. Now, for the next presentation, I like to call presenter Durgesh for the paper title Scoping Review of Research Trend in Artificial Intelligence and Sustainable Investing Using ESG Funds. I request the presenter to kindly proceed with their presentation.
Thank you, sir. Am I audible?
Yes, sir, you're audible. Please proceed with your presentation.
Is it visible?
Yes, sir, it is visible. Please proceed.
Good afternoon, one and all. I am Durgesh Bahuguna, and my paper item is one. Title is Scoping Review of Research Trends in Artificial Intelligence and Sustainable Investing Using ESG Funds. AI technology and advancements within the domain of the sustainable investment is our experience continuous growth, escalating and climatic emergency, expanding the social disparities, increasing the demand of the corporate accountability, have elevated the sustainable finance from the emerging issue to a matter of a global significance. The aim of the research study is to examine the significance of the integration among the AI, ESG, sustainable finance, and sustainable funds through the visualization analysis and the bibliometric tools. Here we have contributed for the business. Here we have found that how the which different kind of fields are contributing for these keywords, and we found the which country is most contributing for the, and which authors are contributing for our fields, and the which prominent universities are contributing for the study. This is the introduction. Artificial intelligence plays a significant role and sustainable finance through the enhancing the ESG processing of information, improving the risk assessment, enabling impact measurement, AI thereby supporting the corporate sustainability and investment decisions. The financial institution examine the huge complicated ESG dataset in the real time, accurate dynamic sustainable initiatives. Adoption of AI has a balance effect on the business environment and social sustainability performance. AI and machine learning are helping hands to numerous industries for the elevation of the sustainable finance and ESG funds. The review shows the AI offers accelerate the progress toward the ESG objectives by enabling the more effective resource allocation, expanding financial participation, enforcement of the sustainable commitments. The environment of the ESG strongly benefits from the AI applications, AI-driven optimization strategies, and boost the energy efficiency and reduce the waste and contributing for the more sustainable resource management. At the end, the combination of AI with the sustainable finance is a critical opportunity. AI boosts the credibility, efficiency, and impact of the ESG investigations. Here, we have used the inclusion and exclusion criteria in the research methodology, where I have used Biosphere software 1.6.20 and the R language BiblioShiny package, and also I have used the Scopus database. CSV file which I have downloaded from the Scopus database, where I have used the key terms, the Scopus AI, ESG, sustainable finance, and ESG funds. The data spans from the 2020 to 2026 has been selected. Around 146 documents were identified, encompassing the article, books, book chapters. The date of the extraction from the Scopus data was 27 November, and in this way, the first result we have observed that the yearly publishing of the document suggested high development phase from the 20 to 25. Around 20 to 21, the documents declines, and which significantly beginning from the expansions, publication continue to accelerate. 3 to 15 in 23 has been observed, and it has been observed there is a great change in 2024 and 25. Here, the second, we have observed the prominent authors called S.S. Agarwal, El Alveri, Cambria, and Darbelli. These are the prominent authors which are contributing for our selected keywords. Here are the prominent organization. So it has been observed that the Indian University, Christ University, which published the maximum documents. After that, the Indian University, Amity University, which and Lovely University, Symbiosis. These are the prominent institutions which are contributing for our fields. Next, the documents uh, by the country. The India has producing the maximum documents in our fields. After the China, Italy, United Kingdom, consequently. So after that, the document types, it has been shown uh, by the help of database of Scopus database. The book chapters are contributing around 37% for our study. Articles are contributing 32%, and it has been observed that business management is contributing maximum producing the documents in the selected keywords. After that, computer science, and next the computer economics, and then energy. Here, the key mappings, it has which is observed that artificial intelligence has maximum co-occurrence, and the key strength is maximum 257. After that, ESG, sustainable finance, ESG funds. These are the top prominent keywords which are the contributing for our study. Here is the key tree mapping, which is I have taken from the by the help of BiblioShiny, which shows that artificial intelligence and sustainable development have participating. The number of documents are the same, around the 10% from our database. So this is the conclusion that the 120 that the artificial intelligence and sustainable finance from the journals published by the Scopus sources, and the top largest contribution is the by from the book chapters, and after that the articles. Artificial intelligence has the strongest links after the sustainable development, and China are publishing high quality of the research papers. After the Singapore, Indonesia, and India are contributing for, and the top authors are the other SS Agarwal and AL Lahotri. And the top universities are the Christ University, Bangalore, India. After that, Amity University and the Lovely Institutes. Here are the limitations. The limitation is that I have used only Scopus database, not I have not used the PubMed IEEE, uh, which is the limitation of my study. And the private sector benefits from the combination of AI, ESG, and the sustainable finance, ESG funds in terms of the operational accomplishment, sustainable growth, risk reductions, and long term of the growth. Through the machine learning algorithm, neural networks, real-time data analysis, exhibiting the assessment of the performance and the risk minimization for the sustainable investing. This is the reference, and this is thank you.
I request a
Hello?
respected session chair, sir. Sir, do you have some
Yes,
questions?
sir.
Okay, Durgesh,
Yes, sir.
you have done your scoping review very deeply. It is good.
Yes.
A simple question consisting of
Yes,
three
sir.
sub questions, 2 to 3 sub questions.
Yes, sir.
How
Yes,
actually
sir.
artificial intelligence is transforming your, we can say, ESG based investment strategies, and what are the current trends, particularly under this AI, are emerging for this particular scoping review. After your scoping review, what you will find that this particular technology is trending as far as AI is considered, and about limitations you already mentioned.
Yes, sir. Sir, how AI is helping? So, sir, AI, mostly, sir, in our finance, the machine learning is helping a lot. Through the base of the different models, we can accurately assess the data, raw data, and we can get the best result, accurate result from these models. So, in this way, sir, AI is helping us for the accurate result from the raw data.
Any specific technique that is emerging as far as your
Sir,
ESG?
sir, yes, sir. Right now, sir, the technology, um, sir, I'm forgetting the name, the rank forest method, which mostly we use it. And
Okay, no issues.
yes, sir.
Shall we proceed, sir?
Finish.
Now, Now we are moving towards the next presentation. For the next presentation, I like to call presenter K. Gopi
Thank you.
Krishna for the paper title Textbook Based Question Paper Generation Using NLP Techniques. I request the presenter to kindly proceed with their presentation.
Sir, good afternoon. Am I audible, sir?
Yes, sir, you are audible.
Okay, sir. I'm going to share my. Sir, is this visible, sir?
Yes, sir, it is visible now. Please.
Yes, sir. I'm Gopi Krishna, sir, and I'm from College Kalasalingam University in Tamil Nadu. So our topic is about textbook-based question paper generation using T5 transformer and NLP techniques, sir. And the team details are here. We are 4 members, sir. We 4 members cooperated and successfully completed the project. And myself, Supraja, Harshavardhan, and Satyanarayana, sir. And when it comes to the title, I have explained this. So the problem statement is about so if we see the manual question paper creation is like time consuming and inconsistent and difficult to scale across diverse academic domains, sir. So here where we mainly focused on different domains, sir. Not only about one domain. So whatever the domain we choose differently, like we can support computer science, it can support IT, it can support electrical, it can support bio, uh, and also different domains. If we see, it is going to support our project, sir. So basically, our project starts from so as we all know, examinations are vital part of education, sir. But preparing question paper is often time consuming for teachers. So we thought that uh, to reduce time consuming and to invite something new, we thought of one idea and we gave one we thought we came out of one good idea, sir. So this is about uh, we implemented one textbook based question paper generation, sir, which reduces time and also a neat question paper it will generate according to our wish, sir. So the question papers will be differently, it will be allocated to the students, sir. Like we are having multiple choice questions and we are having only question based, like we are having marks basis, sir. So as of now, we are focused on marks basis, sir. So our question paper contains 3 sections, each section about different types of marks. So if we see here in this line, here short, medium, and long answer format, sir. So short is about 2 marks, medium is about 8 marks, and long answer it about 16 marks, sir. So this is our stack, sir. So we implemented using one Streamlit using Python, sir. And so here in this Streamlit interface, we are going to download the final question paper as in PDF format. Sir, I will now explain how the question paper will be generated, sir. So basically, our question paper starts from we are having one PDF form. We need to give.
Sir, your screen, your PPT is stuck on abstract.
Yes, sir. I'm explaining on abstract, sir.
Oh, okay, no problem.
Uh, Here in abstract, we mainly focus on how the question paper will be generated, sir. Here we need to post the textbook in PDF format, and it will using NLP techniques. The text will be clearly concise, and it will generate in a line by line. Like we will get sentence by sentence, sir. So it will filter everything paragraph wise, sir. So if we see textbook, we are having only paragraphs, sir. It will segregate every text into tokens, and then tokens into it will chunk every paragraph into tokens, and it will understand what the every meaning of the word by using this project, and it will generate and evaluate the question paper based on easy, medium, and difficult levels, sir. So we are having levels also. So here in this literature surveys, so basically they only focused on how the question paper is generated in manually, but we explained it using T5 transformer by using sections wise, sir. So we can see here 2, 8, 16 marks sections, sir. These are about literature survey. And if we come about if we come from for introduction, sir, here we can see in third point, by processing textbook paragraphs using this model creates correct and semantical relevant questions aligned with original learning material. Like whatever the textbook we are giving to it, it will learn everything, and based on the textbook, it will generate the questions, sir. So it is a original learning material. So the questions will generated by this project is accurate, sir. And the objectives, I'm going to explain the objectives, sir. Here are four main objectives we implemented. So to automate question paper generation from domain-specific textbooks using NLP techniques, sir. So we are going to take any domain-specific textbooks, whatever the textbook like bio, medical, like electrical, we can see a CSE, like computer science and engineering. We are having different textbooks, sir. Like Python, we can take, like we can take biology. We can also take uh, science. We can also take any subject, sir. It will our domain, any domain specific, our project supports, and it will generate a neat question paper, which will save time for the faculties, and also it the work burden will be reduced, and uh, everyone can access the question, like the question paper generated will be very easy, sir. So in that thought, we so this is about our first objective, and the second objective is about to implement a T5 transformer model that converts textbooks content into contextually relevant and grammatically accurate questions. Like the whatever the textbook we uploaded, it will automatically using NLP techniques, it will generate the grammatical mistakes, and using the those techniques, it will generate accurate questions. And if we come for the third point, to develop an intelligent parser for extracting meaningful textual content, like we are having some paragraphs or concepts. So by uploading these textbooks, we can generate the question paper, sir. So the I'm going to explain the methodology. So the methodology is like, so first thing is about textbook input and parsing, sir. So the process just begins with user uploading a textbook in PDF or text format using web application, sir. Here we can see a parser module extracts clean structured content. Like it will generate using paragraphs, sir. By using paragraphs only, it will the parser cleans the text, sir. And if we go for second point, content filtering and selection, sir. Not all textbook content is suitable for question generation. Like we can insert tables, indexes, diagrammatics. We can give anything, sir. And the system applies content selection logic to extract only informative paragraphs of learning objectives. Sir, we can here also extract keyword extracting and semantic filtering also. This project supports, sir. Like the using main keywords also, it will generate the question, and the selected sections are passed as input forms to the T5 model. So everything will be generated and sent to T5 model. Here the transformer model supports in a way like it will transform the text into any kind of language, sir. If suppose I am having the question paper in English format and I want to transform the question paper to Spanish, it will also supports our project supports that also, sir, by using transformer model. So I'm going to make this as a, a, important point, sir, like transformer model. And yes, sir, as just now I have explained about T5 model question paper generation. It will generate text to text transformer model, and it will receive input forms in generate question in paragraph, and the model encodes paragraph contextually and decodes into relevant and grammatical correct questions, sir. Like we are having two processes, sir. It says here encode and decode, sir. So the model encodes the paragraph and it decodes by question paper generation, sir. We can also here our project supports these type of questions also, sir. We are having double H type, fill in the blank based question paper, and MCQ, like multiple choice questions based on the prompt design or based on the user wish. We are going to generate question papers, sir. Sir, this is our architecture model. So we can see here educational content in we are having books, chapters, sentences, NLP techniques, sir. We used some NLP techniques for generating question paper, embedding layer, embedded tokens, input tensor, decoder, output IDs, decoder and output IDs, sir. Sir, here it explains how the user is going to upload the textbook and the process of encode and decode, going to use some IDs. After using IDs and the process, after going through the process, it will generate question paper, sir. Sir, this is existing system, sir. So most existing systems are rule-based methods or traditional machine learning to generate questions. Some focus on multiple choice using distractors or descriptive exams. Sir, mostly every college or some faculties choose like machine learning or AI based, sir. But here our project supports using textbooks, sir. They will simply share or they will simply give the prompt to the topic, whatever the topic they want to generate questions. They will paste the in AI model, sir, and it will generate questions. So going to say that it's not I'm not going to say it is wrong, but it is going to take some time, sir. But if we simply make or if we simply upload whatever the subject in textbook format, it will the model just reads the whole paragraphs or whatever the topics they are having, and it will generate overall question paper. So we made or we thought it is going to easy, and everyone can feel safe, like not safe, everyone can feel easy and to write exams safely and easily in an understandable way, sir. Sir, based on the existing system, we proposed a model, sir. Like it is using TPI transformer model
Sorry
as
to
I before
interrupt, sir,
explained it,
but
this.
you need to conclude faster.
Yes, sir. Sir, I'm going to conclude. Like basically, it is going to take time consuming, and they are confusing like faculty or the universities or any domain. It will support, sir. So I'm going to say that our project our project takes a little time, but it is going a faster output, and we are getting by using textbook based, sir. As of now, everyone prefers textbooks by reading textbooks, sir. So what I'm as a student, I feel about reading textbooks is good, and reading textbooks we will get based on the textbook we are having knowledge, and the knowledge we are having from the textbook. If we write exams, every student will satisfy the question generated from textbook, sir. So this is my conclusion, sir. Sir, if you are having any questions or
Okay,
if
Gopi
you are
Krishna,
having yes, sir.
any NLP specific technique you can mention which is suitable for your automatic question paper generation?
NLP techniques, sir.
Specific technique under NLP.
Like text extraction,
Yes, pardon.
sir.
Which technique?
Text extraction, sir.
Text extraction.
Yes, sir.
Okay, how much percentage of guarantee is assured, ensured as per as alignment of the questions which are drafted in question paper, which are in line with course objective or course outcome?
Sir.
Getting my question?
Yes, sir. Like you're asking about the how much percentage it will prove that only, no, sir.
Yes, yes. Means whether the questions which are getting drafted according to your technique,
Uh,
they are ensuring course objective and course outcome.
yes, sir.
Because if we consider a reference book and
Uh,
if we consider a course for which that
yes, sir.
reference book is assigned,
Yes, sir.
whether that particular drafted question paper is giving the alignment to course objectives and course outcomes.
Yes, sir. I will say like whatever the reference you are saying about the textbook, sir. The user is going to upload in PDF, like the textbook, you are saying no, sir, particular course. So it is going to take the textbook, and based on the textbook, it is going to give the output, sir. Like based on the textbook content, it is going to generate questions, sir. So I can say that it will be proved
Okay,
the
thank
outcome
you.
is good, sir. Good, sir.
Thank you, sir. Now we will be moving forward with the next presentation. For the next presentation, I like to call presenter Diksha Narang for the paper title Deep Learning Based Fatal Health Classification, a Systematic Literature Review. I request the presenter to kindly proceed with their presentation. Ma'am, you're not audible.
Hello, am I audible?
Yes, ma'am. Please continue.
Yeah, just 2 seconds. I'm sharing the screen. Hi, good evening, everyone. I'm Anshika, and today I'll be presenting a research paper, Deep Learning Based Fetal Health Classification, a Systematic Literature Review. This paper was co-authored with Disha Bajaj and Diksha Narang, and we are from Indira Gandhi Delhi Technical University for Women. So we'll start. This will be the flow for the presentation. We'll start with the introduction. So pregnancy is an incredibly complex physiological process, serving as a biological foundation for fetal growth and childbirth. While medical sciences have advanced significantly, pregnancy-related complications and maternal fetal mortality remain severe global health challenges. This particular research is based on the assessment of the methods that are required to continuously uh, to continuously monitor the fetal health, because any imbalance can lead to adverse outcomes. So our goal was to understand that how modern technology can solve this problem. We wanted to see that how deep learning is currently being used to identify the root causes of poor fetal health and support diagnostic strategies. So, this systematic literature review basically revolves around the major four research questions. Uh, so, we carried out this literature review, which is focused around these questions. The first was that what are the specific techniques that are being used for the fetal health assessment? What are the tasks that is actually being performed for the monitoring of the fetal health? What are the research gaps which can be seen in the recent studies? Also, the deep learning methods that are being proposed, how reliable they are in the real life situation. And finally, that what are the common performance metrics that are being used for the evaluation of the proposed methods. Moving on to how to the methodology part, that how we have conducted the literature review. So these are the related works that we have used for carrying out this research. Uh, yeah, methodology. So for the methodology, we have conducted a rigorous search using the IEEE Explore Advanced Search platform. We have set some criterias in order to ensure quality and restrict a particular number of papers for our research. So we only looked at studies that are published between 2020 and 2024 to ensure relevance, and only consider the recent studies. We focused exclusively on the open access journal articles that are published in English. The search string that is being used for deriving these results is fetal and deep learning in the titles or abstract. As you can see, the Prisma workflow. Um, so this is the Prisma diagram that we have drawn for the methodology. So we started with 261 records. After filtering for year, the document type and access, we narrowed this down to 17 high quality papers. basically, these papers were journal papers that are being carried out in this research to perform a holistic review of the deep learning techniques in the fetal health assessment field. So, moving on. So these are the results that we have obtained from the study. So the very first question that was that what are the major techniques that are being used? So in the research, we have seen that there was a shift from the traditional ML methods to DL methods, and even in DL methods, like rather than using simple DL techniques like CNNs or like some basic models, the researchers have moved on to modern technologies like hybrid DL systems, like CNNs with LSTMs, modern models like UNITs and ResNets, by LSTM, RNN networks. In that shows that how DL has improved over the period of time. The second research question was that what are the major tasks that are being carried out for the fetal health assessment? So the major tasks that were seen were classification tasks, which is primarily used for identifying the fetal planes and detecting diseases. Another was the segmentation. Segmentation is basically segmenting the or isolating specific anatomical structures in the ultrasound scans, and the another was detection, where we were detecting some kind of abnormalities based on the data. So the another research question was that what are the gaps and like how what are the research gaps that are being seen in the researches. So the major research gap was data scarcity. There is lack of large, diverse, and annotated data sets because the data set that has to be used is a clinical data set which is validated by clinicians, and that very few hospitals publicize their data sets. So, a data scarcity was the major problem. Also, uh, generalization was another problem because models often fail when tested on data different from machines or hospitals on which they were trained. Another was in the researches that we have considered, there was no uh, interpretability of the models, like the black box model, nature of the model was not uh, explained explicitly, so which lacks clinical validation and which may not make the decision clear, like on what basis is the DL model or any AI model is concluding its results. Another question was that how reliable these models are in the practical field. So many papers report accuracy above 90%, but they still remain uncertain because most studies lack external validation or uncertainty estimation, which reduces confidence in clinical adoption. Another is that what are the performance metrics commonly used for these for fetal health. So we found that accuracy is the standard metrics for classification task, while dice score coefficient is the primary metrics for the segmentation task. I'm moving on to the conclusion and future scope part. So to summarize, we have performed a systematic review of 17 studies that shows a transition in fetal health assessment. We have seen that we are moving from traditional and basic deep learning techniques to more modern deep learning models. And the future work that we have seen and we propose in the upcoming years can be that currently the studies uses only the 2D single plane images. Now with the advancement, there are 3D and 4D ultrasound images too present in the hospitals. Maybe we can integrate 3D and 4D imaging, as well as we can perform multimodal integration in these studies. Also, explainable AI, like unboxing the black box nature of the model, is another future goal where we can build salient maps to see that on what are the primary focus of the model in order on what basis it is deriving the result, which will help the doctors and clinicians to uh, more clearly consider that on what basis is this forming this decision. So Thank you, sir, very much. I'll, any questions? You can ask, please.
Okay, Anshika,
Yes, sir.
what psychological signals are used for classification of fetal health?
Sir, like there were ECG data, uh, like for the mother, and there were ultrasound images like for the fetal. So these kind of data was used to check for the fetal
Is
health
there
assessment.
any parameter FHR fetal heart rate? Have you found any review?
Yes, sir. There was one paper on fetal heart rate, which was considering the ECG scans of the mother. So there were also like gaps found in that paper because that type of data is electromagnetic data and is prone to speckle noise. So that was one limitation of that paper that we found, that the data was a little corrupted, and the like which may result in the like divergence of the final results and outputs.
Which key gaps you have identified after your review?
Sir, like as I mentioned, the like scarcity of data was the major issue. A second was like annotated data sets, because these data sets are manually annotated by clinicians. So like there is no any such validation like if they are annotated correctly or not. Also, data imbalance was also found. Like, let's suppose there were two classes, one for a deceased fetal and one for a normal fetal. So, if you'll see, the abnormal fetal images or the data was relatively less than the normal fetal images or data. So, imbalanced data set was also seen, which was another major gaps in the study.
Okay, thank you.
Thank you, sir.
Thank you, sir. Now we'll be moving forward with the next presentation. For the next presentation, I like to call Hada Harbiun for the paper title Intelligent Prediction of Sustainable Energy Access Using Hybrid Machine Learning and Bayesian Optimization. I request the presenter to kindly proceed with their presentation.
Okay, thank you. Do you hear me now?
Yes, ma'am, you're audible now. Please proceed.
Thank you. En fait, I am Huda Arbawi from Tunisia. So I'm sharing my screen. My name is Huda Arbawi, and today I'm pleased to present our work of sustainable energy access using hybrid machine learning and Bayesian optimization. This work was conducted in collaboration with Emna, Mark Hajamon, and is presented at SMARTCOM 2026. In this
Ma'am,
presentation, introduce the motivation and research context,
ma'am, we request you to kindly
research
switch to the presentation.
research
We are
project,
able to see your Zoom screen
outputs,
only.
solution, the data set. What? Sorry?
We request you to kindly switch to the presentation as we are only able to see your Zoom screen.
You
Zoom
don't you
application.
don't you don't see my screen now?
We are able to see your screen, but on your screen we are seeing your Zoom application, not the presentation.
Okay. Sorry for the noise. And now, do you see now my presentation?
Yes, ma'am. Now it is visible. Please continue.
Thank you. Sorry. Hello everyone. My name is Uda Ahmadi, and today I'm pleased to present our work on the intelligent prediction of sustainable energy access using hybrid machine learning and Bayesian optimization. This work was conducted in collaboration with Emma Hajamor and is presented at SMARTCOM 2026. In this presentation, I will first introduce the motivation and research context. Then, I will explain the research problem, our proposed solution, the dataset, and the methodology. After that, I will present the main results, key insights, and finally conclude with a future research direction. Sustainable Development Goals 7 aims to ensure universal access to affordable and reliable energy. Despite global progress, strong inequalities still exist, especially in developing regions. Energy access depends on complex socio-economic and
Ma'am, we
social
request you to kindly speak a little louder because we are not able to hear you clearly.
challenging. Therefore, encouraging and data-driven forecasting tools are applied to support sustainable energy planning. The main research problem addressed in this work is the difficulty of forecasting energy access accurately. This is mainly due to non-linear relationships between variables and the scarcity of available data in developing regions. Traditional statistical and machine learning models often perform poorly under these conditions. Our objective is to overcome these limitations using a more robust and intelligent approach. To address this problem, we propose a hybrid machine learning framework. This framework combines XGBoost, which it will suited for non-linear data with amazing optimization for efficient hyperparameter training. The, the proposed solution is specifically designed for data-scale environments. We apply this approach to North African countries as a representative regional case study. Our dataset consists of yearly socio-energy data collected at the country level. It includes indicators related to renewable electricity generation. The target variable in our study is the access to electricity indicator. These features allow us to model both energy and economic aspects of sustainable development. The methodology relies on two main components. First, XGBoost is used to model complex and non-linear relationships between the input feature and energy access. Second, Bayesian optimization automatically identifies the optimal hyperparameter, improving model accuracy and efficiency. This combination results in interpretable and efficient learning process. One major challenge of this study is the very short time series available for each country. Individual country-level evaluations are therefore unstable and unreliable. To address this issue, we aggregate data from 5 North African countries into a single regional dataset. This strategy improves statistical reliability while preserving meaningful temporal patterns. The experimental results show strong forecasting performance at the regional level. Um, for example, the area squared value of 0.993 indicates that the model explains almost all the variance in the data. These results confirm the effectiveness of the proposed hybrid framework. Several key insights can be drawn from the study. First, hybrid machine learning models perform very well under severe data scarcity. Second, regional aggregation significantly improves robustness and stability. Finally, the model remains interpretable, which is essential for policymakers and decision-makers. In conclusion, this work presents an accurate and data-efficient forecasting system for sustainable energy access. The proposed approach can support SDG 7 monitoring and evidence-based energy policy. As future work, we plan to integrate uncertain-aware forecasting, satellite-based indicators, and apply the model to other world regions. Thank you very much for your attention.
I request respected session chair, sir. Sir, do you have any questions?
Okay. Uh, you have mentioned some hybrid machine learning technique, no, in your paper, in your
Yes.
presentation.
Yes.
Why it is required means what is its role?
Sorry, can you repeat, please?
Why hybrid machine learning is used in energy access prediction?
Because it performs very well to predict the no, not exact, but so optimum prediction, because it shows results very specific and real.
Okay, and what is the role of that Bayesian optimization in your framework?
En fait, sorry, um, the Bayesian optimization is to optimize and to reduce the errors. You can improve the results uh, after using the Bayesian algorithm.
Okay, and what is the exact use of your role model for the users or for the peoples, for the society?
Normally for the society, but for now we didn't yet work on big data sets, because we don't have all the data sets. So we work on in the future research. We will work on.
Okay, thank you.
Thank you so much.
So, shall we proceed?
Yes, please. Yes.
Thank you, sir. Now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9th version of the conference. We'll be happy to have you in 11th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I also thank our session chair, Dr. Vishal, for chairing the session. Sir, this is the token of love and appreciation from the team of SmartCom 2026 and Global Knowledge Search Foundation and partners. I request you to kindly
Thank
address
you,
our
sir.
participants.
Okay.
Thank you, sir,
Am
for
I
your
audible?
valuable time. Yes, sir, you're audible.
Okay, thank you.
Thank you, sir, for your valuable time. Now I request everyone to kindly turn on their cameras for a quick virtual snapshot. I request everyone to kindly turn on their cameras for a quick virtual snapshot. Thank you, everyone. Have a nice day here. No problem, ma'am. Thank you, everyone. Thank you.